All right, let's look at the questions from the first exam. So the first three are multiple choice. First question. So you want to purchase online access to some horror novels and romance novels to give those out as gifts. There are two different publishers that provide access to those. So before we get into the details, let's first, and I think it's always a good idea to figure out first what your variables are. So how many packages from each publisher should you purchase to meet your need? So the thing that's unknown, the thing we want to learn about is how many packages from each publisher. So I'm going to set those as my variables. There you are, finally. So let's say that X stands for, what's it called? Delta House. So number of Delta House packages, and Y stands for the number of full court press packages. So I have two unknowns. I need to make two equations to solve them, to solve that system. So let's figure out how to make those equations. So now let's get into the details. Delta House offers an access package of 5 horror novels and 5 romance novels for $50. Full Court Press offers a package of 5 horror novels, 11 romance novels for $150. I need to purchase 6,600 romance novels and 4,500 horror novels. So I think I need to make one equation for each genre of book. So for horror, how many horror novels come in a Delta House package? That is 5. So 5 times X. And how many horror movies come in a full court press package? That's 5 times Y. I need that to equal what? So how many total horror novels do I need? That's 4,500. So 5X plus 5Y equals 4,500. And then, so that was for horror. I'm going to set up a similar equation for the romance side of this. So Delta House gives me 5 romance novels. So again, 5X. Full Court Press gives me 11 romance novels. So 11Y. And how many total of those do I need? I need 6,600. So here's my system of equations right here. So lots of ways to solve these. I think the one that jumps out at me is elimination, because both of these equations have a 5x. So what I'm going to do is subtract straight down. So 5x minus 5x, those cancel out. 5y minus 11y, that's negative 6y. And 4,500 minus 6,600, that's minus 2,100. If I solve that for y, what do I get? Should get 350. So I believe I've solved for one of my variables. So let's look at the choices now. I should have full court press, 350 packages from full court press. So that's not this one. That's not this one. Looks like this one that, so it looks like I have my answer, but I really should find what X equals before I choose that. So let's take one of these equations. So 5X plus 5 times Y, which is 350, equals 4,500. 5 times 350 will be 1,750, I believe. Yep. Plus 1,750 equals 4,500. That gives me that 5x equals 2,750. I believe so. 2,750. And then x under those conditions will be x will be equal to 550. So does that line up with our other choice? I believe it does. So I believe our correct answer is here. 350 packages from Full Court Press, 550 packages from Delta House. Moving on to question 2. So according to Delta House, the demand for horror novel access is given by this. So Q is, the number of units, and P is a price point. So basically the price for a single unit. So here's a demand equation. Here's a supply equation. And I want to find what price point puts supply and demand in equilibrium. So basically what that means is my demand will equal my supply. So I think that's how I'm going to start solving this equation. So negative 1000p. So if I have q equals one expression and q equals a second expression, if those q's are equal, then I'm going to set them equal to each other. So a negative 1000p plus 140,000 equals negative 2000p plus 200,000. Let me move my thumbnail. And then I'll start moving things around. I'm going to add 2000p to both sides. So that gives me 1000p. And while we're at it, let's go ahead and subtract 140,000 from both sides. So 1000p equals 60,000. If I divide both sides by 1,000, I get p equals 60. So $60 should be my price point. Do I have an option for that? I do. So correct answer, $60 per novel access. All right, moving on. Question 3. We have a linear programming problem that we want to solve. So I was not, I did not specify whether you should do this by hand or using Desmos. I'm going to go ahead and do it by hand just because I know there's one later that I'll solve using Desmos, but I just want to show you both. So if I'm going to do this by hand, then I really should get all these inequalities in a format where I can graph them. So 8y is less than or equal to x, not x, negative x, plus 23. Divide both sides by 8. So y is greater than or equal to negative 1/8 x plus 23 over 8. So that's one of them. Next one, if I move the 3x over, that one should be done for me. So y is greater than or equal to negative 3x plus 23. And we're also told that x and y have to be positive, so I'm really only looking in the first quadrant. So let's draw just the first quadrant. And before we do any graphing, we should probably figure out what the scales are going to be. So what I'm going to look at is what are the x and y intercepts going to be? So my y-intercepts are going to be 23/8, which is about 3. Yeah, because 24 over 8 would be 3. And 23. So I believe my y scale should go up to, let's say 25. So 5, 10, 15, 20, 25. So 5, 10, 15, 20, 25. What are my x-intercepts? So I believe if x is equal to 23 here, don't take my word for it. Let's actually solve it. So 0 equals negative 1/8 x plus 23 over 8. First thing I'm going to do is this. I'm going to multiply the whole thing by 8. That'll clear all my fractions out. So 0 equals negative x plus 23. X is equal to 23. So there's a y-intercept. What about the other one? 0 equals negative 3x plus 23. 3x equals 23. X equals 23 thirds. That's about 7. So I think I'm going to have the same scale on my x-axis. 5, 10, 15, 20, 25. And I only have 2 lines to graph. I'm going to let the fact that this is the only part of the graph I'm drawing stand in for x is greater than 0 and y is greater than 0. So now let me graph these two lines. Whereas 23 over 8, that's about 3. It's actually really low on my scale. So I'll put that right about here. And what did we say the x-intercept for that one was? That was 23. So about here. And now you get to watch me struggle drawing a straight line. Try one more time. Not terrible. Go ahead and keep it. What does the other line look like? So y-intercept of 23. X-intercept we said was 23 over 3, so about 7. Not a little closer to 8, but somewhere around here. So if I draw that line, So where is my feasible region here? So I want to be greater than or equal to both of those inequalities. So I think my region is out here. Basically, it goes infinitely far up and to the right, as long as I'm in the first quadrant, as long as I'm above these two lines. Okay, so here's my feasible region. Now I need to figure out what the best case scenario in this feasible region is. So what are the corners of this feasible region? It looks like I might have 3 corners, one here, and one down here. But in reality, I only have one, because these x is greater than 0 and y is greater than 0, those are loose inequalities. Sorry, not loose. Those are strong inequalities. I cannot be equal to 0. I have to be strictly greater than 0 in both those cases. So because of that, I believe that my best case scenario is going to be here. So I graphed this by hand, so I wouldn't trust this to find that point exactly. So let's find it exactly. That's where these two lines cross. So let's set those two lines equal to each other. Negative 1/8 x plus 23 over 8 equals negative 3x plus 23. Just like I did last time, I want to clear fractions out. So I'm going to multiply everything by 8. So negative x plus 23 equals negative 24x plus 23 times 8. So that's 160 plus 24, 184. I apologize for whatever work is happening outside my house right now. So now I got this equation free of fractions. I'm going to add 24x to both sides. So I get 23x. And at the same time, I'm going to subtract 23 from both sides. So 23x equals 161, which if we divide, you get x equals 7. If x equals 7, let's plug that back into one of my equations. I think the one that doesn't have fractions is probably better. Negative 3 times 7 is 20, negative 21, plus 23 is 2. So here's the point I get. X equals 7, y equals 2. And we're trying to minimize c equals x plus 2y. So at the point 7, 2, I get that c is equal to 7 plus 2 times 2. That's 11. Just to be safe, we should probably check some of these other choices here. So I believe, based on what I've done so far, that 7, 2 is the best case scenario. Let's go through the rest of these choices though. How about 0, 0? That would certainly give us a better value for C, but I don't think I can use 0, 0. Anything down here underneath this shaded region, that's not a good solution. So I'm going to say no to that. 5, 5. Is 5, 5 a solution? Based on my graph, I don't know if it is. But also, I don't think it matters because their value of C is 15. So let's confirm that. X is 5, 2, yeah, that's, I'm going to throw that one out too, because I have C is equal to 11. So any C value that's bigger than that is no good because I'm trying to minimize. So right now, think about 11 is the lowest that I know about. Anything that's bigger than that is not worth looking at. 0 and 2.875. If you do 2 times 2.875, I don't think you get 23. So I don't even think this answer is correct. And here, I don't think this answer is correct either. If x is equal to 7.667, C is not 23. What about no optimal solution? I think there has to be an optimal solution because at this corner point right here that I'm circling, that solution is 11. So basically we have two options. There's either a better solution than 11 or 11 is the best. So those are the 3 multiple choice questions. Now we have to look at some free response questions. So Your bagel store needs to order cream cheese from 3 different suppliers. So there are 3 different companies. So I have some conditions that I need to meet. So, but like I said before, I think the best thing to do here is to figure out what are our variables. How much cream cheese should you order from each supplier? So I think based on that, I want to know basically for each supplier, how much do I want from them? I think my variables are going to be the different suppliers and how much they provide me with. So X is going to be the Cheesy Cream Corporation. Y will be Super Smooth and Sons, and Z will be Bagel's best friend. So I have 3 unknowns, which means I need to build 3 equations. So let's look at the details now. We need to order 100 tons of cream cheese. So let's be more clear here. For all these suppliers, we're going to be measuring their contribution in tons. So the cost, so I need to order 100 tons. That means if I add my suppliers' contributions together, that needs to total 100. So that's one equation. This comes from, how do you want to say it? Total quantity. All right, that's one equation. This month you need to, okay, we use that. The cost per ton for each supplier is given there. All right. So I know $80 per each ton of cream cheese X, plus $50 for each ton of cream cheese Y, plus $65 for each ton of cream cheese Z. And I need to spend how much? I need to spend $5,675. So this equation comes from my budget. How much money can I spend? And finally, I'm told you'll be purchasing the same amount of cream cheese from CCC and BBF. So what does that tell me? That tells me that X equals Z. So I have 3 equations. I have 3 unknowns. So it's a much different thing to solve a system of 2 equations by hand than a system of 3 equations. So I'm going to set this up in a matrix. So first equation here, I got 1, 1, 1, 100. So X plus Y plus Z equals 100. Next equation, 80X plus 50Y plus 65Z equals 5,675. X equals Z. We got to be a little careful because we're missing details here. So I'm going to get this where everything is on the left-hand side. All the unknowns are on the left-hand side. So X, and I'll also put a placeholder here. X plus 0Y minus Z equals 0. Hopefully that makes it a little more clear why this last row of this matrix goes 1, 0, negative 1, 0. So here's my matrix. We have lots of options for basically reducing these matrices by hand. You can do so in Desmos, among other things. I think the only thing I let you have access to was Desmos. So if you reduce that matrix by hand in Desmos, you should get this solution. 1 second. We should get X equals 15, Y equals 70, and Z equals 15. So 15 tons from CCC, 70 tons from SSS, and 15 tons from BBF. All right, moving on to question 5. So we have a marketing firm that is promoting sneakers. We want to buy 30 commercial spots during 2 different shows. So WWE Entertainment and American Dad. Okay, cost $4,000 per commercial on WWE, $1,000 for American Dad. So first step is not really going to change for me. What are the variables? So what's being talked about here? How many commercial spots did you purchase on each show to maximize exposure? And exposure told is the number of ads times the number of viewers. So the things we want to learn about are how many ads on each, television show. So my two options are WWE. So X was going to stand for how many ads on WWE. Y will stand for how many ads. That's an unfortunate abbreviation. So I'll just write it out. I'm going to write ADAD. So American Dad ads. Okay, so those are my variables. So we have a linear programming problem here. We're not going to solve it by hand, but we should at least, we may have to make the equations to even get to Desmos. So now let's read through this again. So we have to buy at least 30 commercial spots total across these two shows. So what does that mean? I think that will give me this inequality, x plus y. And what is it? So x plus y is something 30. So what sign goes there? I need to buy at least that many. So could be equal to 30, could be more. So I think that's our first inequality. X plus y is greater than or equal to 30. One thing that's not stated here is that, it makes no sense to talk about negative commercials. So okay, so 30 commercial spots during WWE and American Dad. Cost $4,000 for a commercial spot on WWE and $1,000 for commercial on American Dad. And I have my budget. So that's another inequality. So let's number these. 1, 2, 3, and this will be 4. So 4,000 X plus 1,000 Y, and my budget is $390,000. So that's my budget. So I don't think it makes sense for us to spend beyond our budget. Could spend less or equal to. So I think that's a good inequality there. And you need at least 75% of the total commercial spots need to appear on WWE Entertainment. Okay, so this is a little bit, it's probably the trickiest inequality to write here. So I'll show you one way to kind of get here. So 75% of the total number of spots. So what is the total number of ads? I think the total number of ads is X plus Y. And I am talking about 75% of them, or 3/4. So 3/4 of my total needs to be on WWE Entertainment. So 3/4 of my total needs to be related to X somehow. So X stands for the number of ads I'm going to have on WWE. So which one of these, so they could be the same. Which one of these could be more? Let's take it to extremes. Am I allowed to have all of my ads on WWE? I think that would be at least 75%. So I think this one could be less than or equal to X. Because basically X can be larger than 3/4 of the total, but not less. So I think this right here is my fifth inequality. So let's see if there's any more that we have to talk about. You need at least 70%. Okay, forgot that. How many commercial spots did you purchase on each show to maximize exposure? So it sounds like maximizing exposure, that sounds like the thing I want to aim for. So how do I maximize exposure? So it tells us how to calculate exposure. Exposure is equal to the number of ads times the number of viewers. So how many viewers does WWE have? That'll be 3.8 million viewers. I'll just, for now, to make it more manageable, I'll say 3.8. 3.8 times X. plus how many viewers are American Dad? That's 1.5 times y. So we have our 5 inequalities. We have the expression I'm going to try to maximize. So let's do this now. Let's go to Desmos and start plugging these things in. So x plus y greater than or equal to 30. I'm going to leave off the x and y being greater than or equal to 0. I might not need those. It might just be easy to visualize without them. So 4,000x plus 1,000y is less than or equal to 390,000. And 3/4 times x plus y is less than or equal to x. So does this show me everything I need? So I believe this triangle right here that I'm scrolling through, this, I believe this gives me all of my, this is my feasible region. Or is it? It doesn't really make any sense to be looking below the y-axis, so I think we can, let's put one more inequality in here just because I need it. X is greater than or equal to 0. I don't know if that makes it easier to see. Yeah, let's go ahead and leave that off. And we'll know we need to stay above the x-axis here. Oh wait, was that even the right inequality line, I think? Well, that's why it was hard to see, because I didn't graph the right thing. So this region right here, this really dark, like four-sided, this quadrilateral here is our region. So we have our feasible region. So now what can we do with it? Now let's look at the corner points, the vertices. So let's write those down. First one is 22.5, 7.5. So 22.5, 7.5. Next one is 30, 0. Next one is 97.5, 0. And finally, 90, 30. Okay, so the graph, I think, has given us what we wanted it to give us. Let's go back into projecting this. So we have an expression here that gives us exposure, which is the thing we're trying to optimize, the thing we're trying to maximize. A couple of these points doesn't really make sense for X or Y to be fractional. I can't buy half and add. But looking past that, let's go ahead and calculate those anyway. If I start calculating exposure, by this formula here, we'll see that the one that gives me the greatest number is this pointer here, 90, 30. So I'll leave it to you to calculate the exposure for the rest of those points. But the one I get the most from is this point 90, 30, which if we go back to Desmos briefly, that was this upper right, furthest, yeah. So the highest point, and not quite, I wouldn't say the furthest right point, but definitely the highest point, that is going to be where our best case scenario comes from. So that is it for exam number 1.